So in this video we are going to study about the bond order. So what is bond order? The number of the bonds which are present between the two atoms in a molecule is called as bond order. For example, we can see HH, that is the H2 molecule. We can see how many bonds are present. Only one bond is present, and hence we'll say what is the bond order? The bond order is 2. Then we have N triple bond N, that is N2 molecule. Again we can see there are 1, 2 and 3. So how many? 3 is the bond order. Now the very important trick for knowing the bond order is we are going to start with 1, 4, 8, 16 and 20. We just have to remember 1, starting 1 is the 1 0.5. Nextly 4 is always 0. If there are 8 electrons, then the bond order will be 0. If there is 16, we are not going to write anything. Go and find for 20, we have the bond order 0. Means if the electrons are 1, then the bond order is 0.5. If there are 4 electrons, the bond order is going to be 0. If there are 8 electrons, the bond order is 0, and 20 is 0. So how will you learn it? It is 4 stable. So 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 threes are 16 and 20. As we said, 12 and 60 we are not going to take into consideration. So we have 4. So 4, 0, 8, 0 and 20 is obviously 0. So let us look here. So we are going to start with 14. 14 is always 3. So 14 is a permanent number 3. So if there are 14 electrons, the bond order is going to be 3. So as we move downwards, we just have to, so what I told you, we have 20 is 0, so we are going to add 0.5 till we reach 14. Okay, so 19 would be 0.5, 18 would be 1.0, 17 1.5, 16 2.0 and 15 2.4. What did I say? We said 20 electrons bond order is 0, so I wrote 20 and 0. 8 is always 0, so 8 is 0. 4 is 0, and then 14 is always 3, so you just have to add 0.5 from 20 as we move towards 14. So as soon as we reach 14, 3 we have got the bond order. Again we go and we stop at 8. 8 I told you, 8 is 0. So now move downwards, 9, 10. From 9 to 13 we are going to 0.5 to 2.5. Okay, now let us look at the question. If the bond order is 0, then the molecule will never exist, and hence we are not taking 0 here. So now first, find the bond order of Cn+. Carbon is atomic number 6, nitrogen 7 and oxygen 8. If there is a positive charge, we'll subtract 1. If there is negative charge, we'll add. So Cn, that is cyanide, plus carbon 6, add N7 and plus charge is given, so we are subtracting 1. So 6 plus 7 is 13, 13 minus 1 is 12. For 12 we'll find what is the bond order. It's for 12 it is 2. So we are writing the bond order to be 2. Now Cn minus carbon 6, nitrogen 7, minus charge given, so we have added 1, that comes out to be 14, which is 3. 14, 3. Then NO has to be solved like that. Species having same bond order. Okay, so we have to find which species will have same bond order. So it is CO, carbon monoxide and cyanide minus. So carbon 6, oxygen 8 electrons, so it comes out to be 14, and for 14 we have 3. Again Cn minus, it is 6 plus 7 plus 1, 14, which again comes out to be 3. Bond order of O2 minus, O2 plus and O2 you can see and just try on your own. As bond length increases, bond order decreases. Very important. So in this entire video, what is important for you to is know 4 ones are 4, 8, 4, 8, 12, 16 and 20. 12 and 60 we do not take into consideration. 4 is 0, 8 is 0, 20 is 0. So as we move from 20 to 14, 14 is always permanent 3, so add 0.5, add on. From 8 to coming on to the 14, add 0.5. Similarly, from coming out from 4 to 8, add 0.5. Only exception you have to learn is 7 is 0.5. Okay, and 3 is, so exception is 3 and rest all. Always it is asked from 8 to 20, so no need to learn from 1 to 20, just learn from 8 to 20 the bond order. Thank you so much.